My name is Krisztina Jedlovszky, and I'm excited to share our recent research on how our brains handle uncertainty and its connection to experiences like paranoia. You can find these posters at the second poster session, where I'm happy to talk about it in more detail. Our brains are constantly building models of the world around us to predict what's going to happen next. But the world is unpredictable, and sometimes things that make us question if our models are still accurate. When the environment is uncertain, we tend to revise our models more frequently, and some mental illnesses like paranoia might be linked to overestimating this uncertainty, leading us to update our models too much. But how exactly prior ideas about environmental volatility are formed and changed has not been investigated, and my poster describes our work looking into this issue. We conducted an online behavioral task to study prior beliefs about environmental volatility. We used a two-armed bandit task where participants chose between two shapes to earn rewards. Sometimes the rules about which shape was better changed frequently, and sometimes they stayed the same for a while. We called these ones the true blocks. We also had belief blocks. We told participants that the environment would be stable or volatile, but in reality, the rate at which their rewarded shapes changed was exactly the same. This allowed us to isolate and manipulate their expectations about volatility. We looked at the learning behavior of participants with high and low levels of paranoia and how this was influenced by the expected and the experienced volatility. We found that when people expected the task environment to be unstable, they changed their choices more often, just like when the rewarded shapes actually changed frequently. This shows that our expectations about stability and volatility can actually influence how we make decisions. People with higher paranoia also tended to switch their choices more often, as if they were constantly expecting the world to change. As expecting volatility and having high paranoia both led to more erratic decision-making, this suggested a common underlying mechanism that might handle both of these processes. To investigate this further, we fit a reinforcement learning model onto the data and looked at the learning rate and the inverse temperature parameters. Our model showed that the inverse temperature, so the beta parameter, which controls variability in choices, had similar differences across both volatility and paranoia conditions. Simulations using the best-fitting beta parameters also reproduced all key behavioral effects, and there was a significant correlation between the behavioral effects and the beta parameters. Overall, these suggest a common computational basis for both volatility priors and paranoia. In summary, our research provides the first evidence that our explicit prior beliefs about the volatility of our surroundings are integrated into learning and decision-making. Additionally, it reveals a common computational mechanism that could explain the learning differences seen in paranoia. These findings support the idea that learning is influenced by our beliefs about volatility and point to ways that explicit communication might help in addressing unusual beliefs in clinical groups. Thank you so much for listening, and I look forward to discussing this further at the poster session.